Now we will discuss about normal forms based on primary keys. In this section, we will discuss about normalization of a relation, why it is used, and what are the practical use of normal forms, and what are keys, and what are the attribute participating in key, and first normal form, second normal form, third normal form, and BCNF, Boise-Court normal form. Fourth and fifth normal form also there, which are normally used for multi-valued and joint dependencies. So normalization is basically decomposing the tables. We are decomposing unsatisfactory band relation by taking up their attributes into smaller relations. So what is a normal form? It is a condition using keys and FDs of a relation to certify whether the relation schema is in a particular normal form or not. Normalization is generally carried out in practice so that the design are of high quality. The normal forms becomes questionable when the constraints on which they are based are hard to understand or to detect. Generally, we won't go to normalize to the highest possible form. Generally, we will stop at normal form, that is 3NF or maximum of BCNF. So what is denormalization? It's the process of storing the join of higher normal form relation as a base relation which is in a lower normal form. It's just decomposing a relation to the lowest normal form which is possible. Highest normal form which is possible. Now we will define keys and the attribute participating in keys. What is a super key? Suppose we have a relation of n attributes a1, a2, etc. an. A super key is a set of attribute S which is a subset of R with the property that no two tuples t1 of S will be equal to t2 of S. So a key is a super key with the additional property that removal of any attribute from the key K will cause it not to be a super key anymore. So if a relationship has more than one key, each of which is called a candidate key, we can assign primary key as any one of these candidate keys. The other keys are called secondary keys. So now what is a prime attribute? Prime attribute is an attribute which belongs to the candidate key or primary key. It means that it is a part of a candidate key. Those which are not the part of a candidate key are called non-prime attribute. For example, here SSN, ename, birth date is a super key and SSN is a key or primary key. So whatever values which are there, whatever attributes which are there other than SSN are called non-prime attribute. SSN is a prime attribute. So we will move on to first normal form. By definition, first normal form should have no multi-valued attributes, composite attributes and their combination. There should be only atomic values. Also it disallows set of values, tuples of values or combination of both as attribute values. So the example is given on the right side figure. See, department, the table department is there where D number determines D name, D MGR SSN and D locations. When an instance is taken, we can see that the department research with department number 5 have multiple values which are given in the D location. So what we will do, we will keep the separate values in the table like it is shown in the C, but which is a 1NF relation with redundancy. Also we will keep D name and D location as the key to identify the table. Here is another example where nested rotations are there. The project is having P number and P hours, and for a particular employee he will belong to different projects and the project hours will be different. Here what we will do, we will split the employee project into two tables like employee project 1 and employee project 2 by propagating the primary key. So employee project 1 will hold SSN and ename, and employee project 2 will hold SSN, P number and hours, where SSN and P number will act as a primary key. Okay, now we will move on to second normal form. A relation schema R is said to be in second normal form if it is in first normal form, and every non-prime attribute A in R is fully functionally dependent on the prime key or the prime attribute. So we will take an example on the right hand side. We are taking an example of employee project where SSN and P number are primary key, or it's a candidate key. Here we have the functional dependency. The FD1 is SSN, P number determines hour, SSN determines ename, which is the second functional dependency, and P number determines P name and P location. As we can see that apart from SSN and P number, the others are non-prime attributes. So the non-prime attribute should be fully functionally dependent on the primary key. It means that it should be dependent on the primary key in a full form. So here SSN gives ename. Ename is a non-prime attribute and it is partially dependent on SSN. So it violates the second normal form. Also P name, P location is partially dependent on P number. So which is not holding in second normal form. These both violates the second normal form. So what we will do, we will split the table as given below. See EP1, EP2 and EP3. So we will split it based on the functional dependencies. The first one, for the first EP1 relation, we will keep SSN, P number and hours. So the FD will hold on there. And the next one is SSN gives ename is taken in that relation, so it will hold there, and P number, P name, P location is separated, so that functional dependency will also hold here. So then now what the rule says, every non-prime attribute of A in R is fully functionally dependent on every other non-prime attribute. So next is third normal form. Before going to the third normal form, we should know what a transitive functional dependency is. So if X is determines Z, that can be derived from two FDs, X determines Y and Y determines Z. We say that there is a transitive dependency. For example, SSN determines D and GR SSN is a transitive dependency. Why? Because SSN determines D name, D number is there, and D number can determine DMGR. So SSN can directly determine DMGR SSN, which is a transitive dependency. So for a relation to be in 3NF, it should be in second normal form, and no non-prime attribute A in R is transitively dependent on the primary key. The definition is like this: a relation schema R is in third normal form if whenever an FD X determines A holds, the two conditions should be satisfied. X is a primary key, X is a super key of R, or A is a prime attribute of R. The example for 3NF is given in this slide. You can see the B example is for 3NF. Here SSN determines ename and other things, and D number determines DName and DMGR SSN. As SSN determines DName and DName determines DMGR SSN, it is a transitive dependency. We are splitting the table into two. We are keeping D number in one table with SSN, and we are keeping another one D number and DName and D location. That's how we are eliminating the problem of third normal form, and now it is in third normal form. So what is a BCNF? BCNF, we will remove the second condition in a third normal form. So for a BCNF, the condition is like it should be 3NF, and for X determines A, X is a super key of R. So every second normal form is in first normal form, every third normal form is in the second normal form, every BCNF is in third normal form. So the goal is to have each relationship in 3NF or BCNF, as I said earlier.